I am Milay Kumar, working as an assistant professor, Department of Physics, in St. Joseph College of Arts and Science. Dear students, in this video, I am going to discuss about the Compton scattering and its experimental arrangement, then its definition, direction of the recoil electron, and the energy, that means kinetic energy of the recoil electron. First, you see the what is meant by. So Compton effect is nothing but a elastic interaction. So elastic interaction, otherwise called as a Compton effect. So what happens here? The scattered beam contains two wavelengths in addition to the original wavelength. That means expected wavelength is due to loss of energy of the incident X-rays. So Compton discovered when X-rays of a sharply defined frequency when incident on a material which having low atomic number like carbon, so then there is a change of frequency on scattering. So it suffered somewhat change in frequency while on scattering. So thus the scattered beam contains two wavelengths in addition to the expected wavelength is due to loss of energy of the incident X-rays. So this elastic interaction is known as Compton effect. Compton effect is due to incoherent scattering due to change in wavelength and its directions. So there is a change in wavelength and direction gives a Compton effect due to incoherent scattering. So here we explain the Compton effect based on quantum theory of radiation. It's nothing but collision between the X-ray photon and electron. So this effect was explained by Compton on basis of quantum theory of radiation. This means the whole process is treated as a particle collision event between X-ray photon and the loosely bound electron of the scatterer. So in this process, both momentum and energy are conserved. What happens in the photon electron collision? A portion of the energy of the photon is transferred to the electron. As a result, the X-ray proceeds with less than the original energy. So here h nu will give the energy of the incident photon and h nu by c which gives the momentum of the photon, h nu dash which represents the energy of the scattered photon. Then h nu dash by c which gives the momentum which moves off in a direction inclined at an angle theta which was mentioned in the diagram. So in the diagram I mentioned the two angles theta and pi. Here the theta gives the momentum which moves off in a direction inclined at angle theta. And mv which represents the momentum of electron moves at an angle pi to the original direction, for recoil electron direction. So the energy of the recoil electron is mc square. So next one. So according to the principle of conservation of energy, we may write as h nu plus m naught c square which is equal to h nu dash plus mc square. Put as equation number 1. So then considering the x and y components of the momentum and applying the principle of conservation of momentum, we get h nu by c, which is equal to h nu dash by c into cos theta plus mv cos pi. Put as equation number 2. And h nu dash by c sin theta minus mb sin pi, which is equal to 0. Put as equation number 3. From 2, we may write as mbc cos pi is equal to h into nu minus nu dash cos theta. Put as equation number 4. Then from equation number 3, we may write as mbc sin pi, which is equal to h nu dash sin theta, which gives equation number 5. Then squaring and adding equation number 4 and 5, we get m square v square c square, which is equal to h square into nu square minus 2 nu dash cos theta plus nu dash square into cos square theta plus h square nu dash square sin square theta, which gives h square into nu square minus 2 nu dash cos theta plus h square nu dash square, which is equal to h square into nu square minus 2 nu dash cos theta plus nu dash square. Equation number 6. Then from 1 we may write the equation as mc square, which is equal to h into nu minus nu dash plus m naught into c square, which gives m square into c power 4, which is equal to h square into nu square minus 2 nu dash plus nu dash square plus 2h into nu minus nu dash into m naught c square plus m naught square c power 4, which gives equation number 4. Subtracting equation 6 from 7, we get m square into c square, which is in c square minus v square, which is equal to minus 2h square nu dash into 1 minus cos theta plus 2h into nu minus nu dash into m naught c square plus m naught square c power 4. Equation number 8. The value of m square into c square to c square minus v square can be obtained from the relativistic formula. So m equal to m naught by root 1 minus v square by c square. This is the relativistic formula for the mass energy relation. Squaring on both sides, for the relativistic formula we get m square, which is equal to m naught square divided by 1 minus v square by c square, which is equal to m naught square into c square divided by c square minus v square, and cross product we get m square c square into c square minus v square, which is equal to m naught square c power 4. Put as equation number 9. Then from 8 and 9, we write the equation as m naught square c power 4, which is equal to minus 2h square nu dash into 1 minus cos theta plus 2h into nu minus nu dash into m naught c square plus m naught square c power 4. On rearranging those equations, we get 2h into nu minus nu dash into m naught c square, which is equal to 2h square nu dash into 1 minus cos theta, or nu minus nu dash by nu dash, which is equal to h by m naught c square into 1 minus cos theta, or we may write as 1 by nu dash minus 1 by nu, which is equal to h by m naught c square into 1 minus cos theta. Then we can multiply the c factor on both the left and right hand side of the equations. We get c by nu dash minus c by nu equal to h by m naught into c into 1 minus cos theta. We know the value or relation between lambda, c and nu. On base that relation, we may write as c by nu equal to lambda. So we can get lambda dash minus lambda equal to h by m naught c into 1 minus cos theta. Put as equation number 10. Since there is a change in wavelength, for lambda dash minus lambda, here we put d lambda, which gives h by m naught c into 1 minus cos theta. From this relation, we may conclude d lambda is independent of the wavelength of the incident radiation as well as nature of the scattering substance. It purely depends upon the angle only. That means scattering angle only. Thus the change in wavelength depends the angle of scattering only. Now we can discuss the three cases for this change in wavelength. Case 1. When theta equal to 0, what happens? Cos theta value 1. So now we substitute those cos theta value in the above equation, we can get d lambda equal to 0. Case 2. When theta equal to 90 degree, cos 90 value 0. So we get d lambda equal to h by m naught c equal to 6.63 into 10 power minus 34 for Planck's constant divided by rest mass of electron, which gives 9.11 into 10 power minus 31 into velocity of light 3 into 10 power 8. We get the final answer as 0.0243 Armstrong. So this wavelength gives the Compton wavelength. Case 3, when theta equal to 180 degree, cos theta equal to minus 1 hertz, the d lambda gives 0.0485 Armstrong. So for this angle, d lambda is the maximum value. Experimental verification of the Compton scattering. This is the diagram for the Compton scattering. When we pass the monochromatic X-rays of wavelength lambda through a small block of carbon material, there is a bag spectrometer. There we received the scattered X-rays. The bag spectrometer, the scattered waves are received. The spectrometer, which is freely swing in an arc about the scatterer. So from the Coolidge tube we can get the monochromatic X-rays. Then through a small block of carbon material which is placed at the Bragg spectrometer, the Bragg spectrometer which is freely swing in an arc about the scatterer. So in this graph we have to draw the value for intensity and the wavelength. So for different wavelength we mark the intensity value for the radiations. So there is a change in radiation for different angle. So there is a gradual decrease in d lambda value for different theta value. That is a theta equal to 0, theta equal to 45, theta equal to 90, theta equal to 135. So for increase in angle, there is a change in wavelength also increases. That's the conclusion from this graph. So the wavelength of the scattered X-rays is measured for different values of the scattering angle. So this graph shows the experimental results of the Compton scattering. Thus the scattered radiation, in addition to the incident wavelength lambda, there exists a line of longer wavelength lambda dash. Thus the Compton shift d lambda is found to vary with the angle at which the scattered rays are observed. Next, find out the direction of recoil electron. So here, dividing the equation number 5 by equation 4, we get tan pi equal to h nu dash sin theta by h into nu minus nu dash cos theta, which is equal to nu dash sin theta divided by nu minus nu dash cos theta. Put as equation number 11. Here h and h gets cancelled. Using equation 10, we get 1 by nu dash, which is equal to 1 by nu plus h by m naught c square into 1 minus cos theta, which is equal to 1 by nu plus h by m naught into c square into 2 sin square theta by 2, where 1 minus cos theta equal to 2 sin square theta by 2 is a mathematical formula, comes under trigonometric relations. Or nu dash, which is equal to nu by 1 plus h by m naught c square into 2 sin square theta by 2, which gives nu by 1 plus 2 beta sin square theta by 2, where beta equal to h nu by m naught into c square. Put as equation number 12. Now substituting this value of nu dash in equation 11, we get tan pi, which is equal to nu sin theta by 1 plus 2 beta sin square theta by 2 divided by v nu minus nu cos theta divided by 1 plus 2 beta sin square theta by 2, which gives cot pi by 2 divided by 1 plus beta. So how we get the value cot theta by 2 divided by 1 plus beta? So on the right hand side, here I derive the answer for cot theta by 2 divided by 1 plus beta. So you have taken the tan pi value nu sin theta divided by 1 plus 2 beta sin square theta by 2 divided by nu into 1 plus 2 beta sin square theta by 2 minus nu cos theta divided by 1 plus 2 beta sin square theta by 2. So here we cancel the 1 plus 2 beta sin square theta by 2 divided by 1 plus 2 beta sin square theta by 2. So we get the second equation. There v and v value gets cancelled. In the numerator and denominator we have common nu value gets cancelled. So we can get 2 sin theta by 2 cos theta by 2 divided by 1 minus cos theta plus 2 beta sin square theta by 2. Further simplification, we get 2 sin theta by 2 cos theta divided by 2 sin square theta by 2 into 1 plus beta. So we can cancel the numerator and denominator value of 2 sin theta by 2. So we can get only in the numerator term cos theta by 2. So cos theta divided by 2 divided by sin theta by 2 into 1 plus beta, where cot theta by 2 equal to cos theta divided by 2 divided by sin theta by 2. So we can get cot pi by 2 divided by 1 plus beta. So finally we can get tan pi equal to cot theta by 2 divided by 1 plus h nu by m naught c square. Put as equation number 13. Kinetic energy of recoil electron. It possesses some energy when moving, so we call as kinetic energy of recoil electron. The kinetic energy of recoil electron is the difference between the energies of incident and scattered photons. So there is a energy difference between the scattered photon and incident photon. This will tells the kinetic energy of a recoil electron. So we write as kinetic energy equal to h nu minus h nu dash. Here h nu for incident photon, h nu dash for scattered photons. Then kinetic energy, which is equal to h nu minus h into nu minus 1 plus 2 beta sin square theta by 2. On further simplification this equation, finally we can get h nu into 2 beta sin square theta by 2 divided by 1 plus 2 beta sin square theta by 2. Put as equation number 15. We know the beta value, where beta equal to h nu by m naught into c square. So this is the final expression for the kinetic energy of recoil electron. So in this video, first I explained the concept of what is meant by Compton effect. Then incoherent scattering between the X-ray photon and a loosely bound electron. Then you can derive the principle of conservation of energy. Then finally we can find out the d lambda value as h by m naught c into 1 minus cos theta. Then we discuss the three cases: theta equal to 0, theta equal to 90 degree, then theta equal to 180 degree. Then we move to experimental verification for the Compton scattering. Finally, we can derive the value for direction of recoil electron and the kinetic energy of recoil electron. Thank you, students.